In the vast, cold expanse of the Kuiper belt, Pluto emerges as a mysterious object among celestial bodies, its distant location and unique characteristics setting it apart. The region that truly captured global attention was Tombo Regio, particularly its heart-shaped area, which was revealed when NASA's New Horizons spacecraft sent back its first close-up images of Pluto. Within this heart lies Sputnik Planitia, a bright basin with high reflectivity, set against darker surroundings. This discovery raised immediate questions. How did this odd, pear-shaped basin form? And why is it so near Pluto's equator? The answer to these questions may lie in a dramatic event that took place billions of years ago, when the stillness of the outer solar system was disrupted by the collision of celestial bodies. In a recent study, scientists proposed that Sputnik Planitia isn't merely a surface feature but the remnant of a massive impact. The material from the impactor, they suggest, still lingers beneath the nitrogen ice, hidden from view. This collision theory posits that the basin is not just a random formation, but rather a scar from a monumental impact event that shaped Pluto's surface in a profound way. Researchers used sophisticated smooth particle hydrodynamics, SPH, simulations to model the conditions that might have led to the formation of Sputnik Planitia. These simulations provided a glimpse into Pluto's violent past, helping scientists reconstruct the event that led to the creation of this unusual basin. The simulations showed that Pluto, with its icy outer crust and rocky core, withstood the impact without breaking apart, a sign of its resilience. This resilience, scientists suggest, is a result of the unique physical environment in the outer solar system, where icy bodies like Pluto exist in extremely cold conditions, which influence how they respond to impacts. One of the more counterintuitive findings from the study is that Pluto's relatively small size might have helped it survive the collision intact. Because Pluto has a lower gravitational force compared to larger planets, the material strength of its icy and rocky layers was not entirely overwhelmed by the force of the impact. The impact itself was likely subsonic, meaning that it occurred at a slower speed than collisions that typically happen at much higher velocities in the inner solar system. This slower impact allowed Pluto's icy shell to absorb the force without completely disintegrating, leading to the formation of the pear-shaped basin. As the impactor's rocky core moved through Pluto's icy shell, it encountered resistance, which is believed to have contributed to the distinct shape of Sputnik Planitia. Eventually, the core settled deep within Pluto, leaving behind a splat of foreign material. This scenario differs from other theories that suggest the presence of a subsurface ocean beneath Sputnik Planitia. Instead, the researchers propose that the core of the impactor, now buried within Pluto, is responsible for the gravitational anomaly observed in this region. This buried core might also explain why Sputnik Planitia is located so close to Pluto's equator. Over time, the gravitational influence of the impactor's core may have caused Pluto to undergo a process called true polar wander, in which the planet's outer shell shifts, relocating surface features to new positions. In this case, Sputnik Planitia may have slowly migrated from a higher latitude to its current near-equatorial position due to the gravitational imbalance created by the impact. The study's implications extend beyond Pluto, offering new insights into how planets and other celestial bodies evolve in the outer solar system. Unlike the inner planets, which are warmer and larger, objects in the Kuiper belt experience vastly different conditions that allow for the preservation of ancient geological features. In these colder, distant regions, monumental impacts like the one that formed Sputnik Planitia may remain frozen in time, their traces preserved beneath layers of ice and rock. This research challenges previous assumptions about how impact events shape planetary surfaces. On larger, warmer planets closer to the Sun, geological activity tends to erase the evidence of such collisions over time. However, in the frigid, less active environments of the outer solar system, these scars can endure for billions of years, offering scientists a unique window into the history of these distant worlds. Pluto's surface, with its complex mix of ice and rock, may hold on to the remnants of other collisions, making it a rich site for further exploration. In addition, this study sheds light on the potential for foreign material from impactors to remain embedded in Kuiper belt objects long after the initial collision. These bodies, which orbit far from the Sun, may harbor large amounts of material from other celestial objects, trapped beneath their icy exteriors. This discovery raises intriguing questions about the composition of Pluto and other objects in the Kuiper belt. Could these distant bodies contain more foreign material than previously thought? And if so, what does this mean for our understanding of planet formation in the outer solar system? The study of Sputnik Planitia is not just about understanding Pluto, it's about expanding our knowledge of how celestial bodies evolve in the most remote parts of our solar system. As we continue to study Pluto and other Kuiper belt objects, we may uncover new clues about the processes that have shaped these distant worlds. Sputnik Planitia, with its pear-shaped basin and buried impactor, is just one piece of the puzzle, but it offers a tantalizing glimpse into the complex history of our solar system's outermost regions. Ultimately, this research underscores the importance of continuing to explore the outer reaches of our solar system. With missions like New Horizons, we have begun to unlock the secrets of these distant worlds, but there is still much to learn. Pluto's icy heart, shaped by the forces of cosmic collisions, reminds us that even in the farthest corners of space, the story of our solar system is still unfolding.